The second half of section 8.5 is a review on rationalization. So rationalization in math class means something very specific. So just as a brief refresher, to rationalize something, you cannot actually, so this occurs when you have a fraction of some kind, so a numerator and denominator. So you can either rationalize the denominator, but you can also rationalize the numerator. And doing one or the other just depends on what you're using your expression for. Okay, so what it means, if you take a look down at the examples, right, it has to do with roots of some kind. So generally roots are not considered rational because they tend to not be, they tend to be irrational when you plug things in most of the time. Okay, so what it means is if you're going to rationalize a denominator, it means to find an equivalent algebraic expression using algebra. Whoops. Yeah, so to find, right, what do I want to say? Let's say to use algebra, and I'll show you how, to find an equivalent expression. So one that means the same thing, but maybe it just looks a little bit different. Where the numerator or the denominator has the radicals moved around. So without the radical in the denominator, if we're rationalizing the denominator, or without the radical in the numerator, if we are rationalizing the numerator. So that's what to rationalize means. When you are rationalizing, you will never be able to just get rid of the root. You'll never be able to just get rid of it. You're just going to move it around. So if you rationalize the denominator, you will be introducing a root in the numerator. If you rationalize the numerator, you will be introducing a root in the denominator. Okay, so it'll never go away. And you will never accomplish this by just randomly squaring things. Okay, so there's a very particular way to do this, and it's really the only mathematically sound way to do this. It does not involve squaring. Okay, so let's just say this does not involve squaring the numerator and the denominator. Okay, so let's just start with rationalizing one term. Okay, so by that I mean in the numerator or the denominator, we just have a root. There's not the root plus or minus anything or vice versa. So we'll look at that case in just a second. So when you're rationalizing something with one term, what you want to do is multiply by, and I'm just going to write this as a square root over square root. Square root of whatever it is over square root of the same whatever it is. So for example, in number 1, we have 2 over the square root of x, and we want to rationalize the denominator. Okay, so we can't, like I said, we can't just go squaring the top and squaring the bottom to get rid of it. You're actually changing the whole thing if you randomly apply squaring. One thing we can do is multiply by a fancy version of 1. And that fancy version of 1 that we're going to multiply by is, so you look where what's in the radical, and that's in the denominator here, we have square root of x. So we just want to multiply by square root of x in the bottom, and then we also have to do that in the top. And what ends up happening is when you multiply fractions together, you multiply across the numerators, so that'll be 2 times radical x. And then you multiply across the denominators, so that's radical x times radical x. And when you multiply something that's under a root times the same thing, you're essentially squaring it. And so the root goes away, and what you're left with here is just x. Okay, so this will be 2 radical x over x. And so you see, we've accomplished what we wanted to do. The denominator is rational, meaning that there's no root or no radical, but it's not gone all the way. It's in the numerator. And again, that will always happen. So here we go. Here's the equivalent form of that where the denominator is rational or rationalized. Okay, example 2, we've got 3 over the square root of 5 plus x. Why don't you pause this and try this on your own? Okay, what we're going to do is the same thing. We have the square root of 5 plus x in the bottom. So to rationalize the bottom, we're going to multiply by a fancy version of 1. And that's the square root of that same stuff, 5 plus x in the bottom. And then we also have to do it in the top. Okay, when we do that, we will multiply the numerators across. That'll just give us with 3 times the square root of 5 plus x. We multiply the denominators across. That's just radical 5 plus x times radical 5 plus x. Okay, in the denominator, we have the square root of something times the square root of the same something. So that just equals, the roots kind of go away. So we just have 5 plus x in the bottom. And in the top, we just have 3 radical 5 plus x. And there we go. Again, notice that the denominator now does not have a root or a radical, but the numerator does. But that's okay. If we try to rationalize the numerator here, we're just going to get back to where we started. So it's a vicious cycle. You just, for whatever reason, we will have reasons very soon, we will want to be rationalizing. Okay, so one term, this is how it's done. Let's take a look at how to rationalize with 2 terms. So in our first example, well, actually, let's review how to do this. So when you have 2 terms, if you look at the first example, what I mean by that is you got like a root and then plus outside of the root, plus or minus something else. Okay, so in the second example, we've got, something minus root. So it's like got 2 parts to it. Okay, when that's the case, multiplying by just radical x here isn't going to cut it because that's going to need to be distributed here and here. And when you distribute radical x into the 5, that's going to have radical x in it. Not rational. So the way to rationalize something in this form is to multiply by what is called the conjugate. And if you're going to do that in the bottom, you also have to do it in the top. So you're going to multiply by the conjugate over the conjugate. So here's an example of what a conjugate is. Let's just make like a little list here. Conjugates. The conjugate of A plus B, conjugate of something plus something, you just change the sign between them. So it'll just be A minus B. So vice versa, the conjugate of A minus B is A plus B. Okay, the A and the B, the first thing and the last thing stay the same, the sign between them changes. Also, if there's like radicals involved, like in one or more parts, a radical A plus B, it would still be the same idea. You just change the sign between them. Okay, if the square root were in, the other term, like in the B part, so you would do the same thing. It doesn't matter. Okay, the conjugate of that would just be a minus, but everything stays the same. And even if there's a root or a radical in both of those terms, the conjugate is the same with just a minus instead of a plus. Okay, so here we go. So let's see what happens when we multiply by the conjugate in this first example and why that makes the radical go away. Okay, so in this these two examples, we're trying to rationalize the denominator. So we want to look to the denominator to help us determine what the conjugate is, right? So we've got radical x plus 5. Okay, that looks just like this, right? So we're going to leave the radical x and the 5 and then change this to a minus in order to find the conjugate. Okay, so this will be radical x minus 5. Radical x minus 5. Now be careful, we have like binomials here, so two terms. When we're multiplying, we should really be putting parentheses around everything. Okay, when we multiply fractions together, we multiply their numerators and we multiply their denominators. Oops. Now we haven't quite done the job yet. This is not yet rationalized. In the numerator, we can leave that exactly as it is. There's no reason to distribute the x. It's like kind of factored. And in the bottom, our goal is to rationalize this. So here we want to figure out what that product is. So when we have these things multiplied out, what will end up happening is we're like kind of reverse factoring a difference of two squares, right? Because do you guys remember when we were reviewing factoring, right? If we were to say, factor, I don't know, I think we factored x squared minus 25, right? This would be factored into x plus 5, x minus 5. So what we're doing is basically going this way. So when you multiply out things like this, the middle term falls out and you just end up squaring the first part, right? X would be x squared. And you square the second part, the 5 here, to give you 25, and then it's a minus between them. Okay, so if we have more generally, let's write down like a rule for this, I guess. So if we have like square root of, well, we can just do it with this example. Let's do square root of x plus 5 times square root of x minus 5. Okay, what we're going to do is we could FOIL, so we'll have square root of x times square root of x. That's just x. Then we have the outer. This is minus 5 radical x. Then we have the inner. This is plus 5 radical x. And then we have the last, 5 times negative 5. That's minus 25. And you see here that the middle term cancels out. And that will always happen. Okay, so what we end up here, we end up with is x minus 25. Okay, so what we'll get is the square of the first thing here, okay, radical x squared, and then always minus the square of the second thing. Okay, so what this will end up being, so we want to multiply out or use the shortcut that I just described, like square each, oh, what am I trying to spell here? Use the shortcut where we just square each of the parts. So let's do x times radical x minus 5. Then this will be x minus 25. And there we go. This is rationalized in the denominator. So we accomplished our goal. Okay, why don't you try the second example? So pause this video and try example number 2. Same thing, you want to rationalize the denominator. Okay, so you're looking to the denominator to figure out what the conjugate is. Okay, so we've got 6 minus radical x. So the conjugate is going to be 6 plus radical x. So let's go ahead and multiply both top and bottom in parentheses everywhere by 6 plus radical x. iPad, wake up. Okay, there we go. So let's see. Here, remember what we said in the last example. In the numerator, always leave it. Okay, never bother FOILing out the numerator. So what I'm saying is leave it as x minus 36 times 6 plus radical x. Just leave it. It's fine. It's not part of our goal here to make that any different. We just want to rationalize the denominator. Okay, in the denominator here, again, either we're going to multiply these together. So let's see, I'll just write that down. So we've got 6 minus radical x times 6 plus radical x. Again, we're going to leave the numerator. In the denominator, we're going to use the shortcut, or you can multiply it out. So we're going to square the first piece, 6. That gives us 36. We're going to square the second piece. Radical x squared is x. And then it's always a minus between them. Now we could stop here. I mean, we did accomplish our goal. We have rationalized the denominator. However, if you look at the factor here, x minus 36, we have 36 minus x in the bottom. Those are kind of similar. They're not exactly the same, but they're the opposites. So we can cancel these out, except because their order was swapped, right, and we're subtracting, one of them is equal to the negative of the other, okay, because the signs are reversed. So when you cancel things like this, instead of getting a 1, we're going to get a negative 1. Okay, so this will end up becoming negative 1, or I better just write it as negative, parentheses, 6 plus square root of x, or negative 6 minus square root of x. And there we go. Yet another reason why you do not want to kind of FOIL out the numerator here, because if you did, you would not be able to see that we can cancel these out and make it for sure simpler than if we didn't. All right, example number 3, before I've got this crazy challenge example here. Don't look at that yet. Let's just try example number 3. Again, pause this video and try to work this out on your own. The instructions still are to rationalize the denominator. Okay, so you're looking at the denominator to figure out what the conjugate is. And of course, that will just be radical x plus radical x minus 4. Same thing, top and bottom. Now notice that the sign that is inside of the radical here does not change. It's only the sign that's between the two things here involving the radicals or whatever. Okay, now I'm missing parentheses. Let's make sure we put all of that around here. Okay, now multiplying these into a single fraction. Here's our numerator, just 4 times all of that stuff. Again, there's no need to distribute the 4 or anything. We can just leave it just as it is. Now in the bottom, when we multiply this in parentheses times this, we need to FOIL it all out, but you can use the shortcut always. We're going to square the first thing. Okay, so radical x, if you want to even write it out, we can do that too. So we're going to square the first part. We're going to square the second part, which is the square root of x minus 4. And then it's always a minus between them. Okay, always square each thing, then subtract. Okay, so let's see what we get here. Again, in the numerator, let's just leave it as it is with the 4 factored out. Then in the bottom, radical x squared is x minus the square root of x minus 4 squared is x minus 4. Okay, but we're subtracting all of that, so we need to make sure we've got parentheses here. Now, lastly, in the denominator, I know I said mostly, you're done once it's rationalized, which it is at this point. However, we can simplify. So we have x. Let's see what we'll have here. If we distribute the minus, we'll have, let's see, numerator will stay the same. Okay, we'll have x minus x, and this will become plus 4. You know, x minus x, those cancel out or add up to 0. So this will give us 4 times radical x plus radical x minus 4. And then we're dividing by 4. Wow, sorry, iPad's having a really hard time keeping up. Anyway, so we've got 4 times a bunch of stuff, and then you're dividing by 4. So those just, divide to give you 1, right? So this actually just simplifies to the square root of x plus the square root of x minus 4. And there we go. We have rationalized the denominator. Again, we've moved the roots around, but we accomplished what we wanted to do. There will be an important reason for this in the very near future, but for now it's just fun to be able to do this. In this last example, we're going to combine together both of the things that we've been talking about in this section. And that is, getting a common denominator to combine fractions together, and also a little bit of rationalizing. Okay, so in this example, we've got this crazy looking thing. It is a complex fraction, a fraction within another fraction. There's roots involved, and it's just overall a little intimidating. In calculus, we will be calculating things that are called derivatives, and this expression is actually the result of calculating the derivative of a certain function. And so we will see this at some point in the near future, and we will want to simplify it to work with. Okay, now, so simplifying in this case will generally mean like to get a single fraction. Complex fractions are not simple. So that's kind of what we're going to be aiming for here. Not necessarily rationalize, it doesn't always mean simpler, but definitely a single fraction. So first, let's work with just the numerator here. Okay, just the numerator. So to get a common denominator, what we can think of is this as this first part as being over 1. And so the common denominator is going to be just what the denominator of the second fraction is, right? 2 radical x plus 1. So what I'm going to do is I'm just going to make sure I don't lose this piece here. So I'm just going to write that because we're not working with that yet. Okay, and what we're going to do is multiply the first fraction here, okay, by 2 radical x plus 1 over 2 radical x plus 1. Okay, now let's see what that gives us. So in the, this part where we're multiplying fractions together in the numerators, we're going to multiply across. Okay, so we're going to have a 2 times, and then the radical x plus 1 times radical x plus 1, that's just going to become x plus 1 in parentheses. Okay, the denominator there will be 2 times radical x plus 1. Then we still have minus x over 2 radical x plus 1. All right, now we have a common denominator in the numerator of this whole thing, right? So I'm just looking here with these fractions here. So again, I'm just going to write this whole big divided by so I don't forget. And then we can put these together into a single fraction. Okay, so this will be 2 times x plus 1, then minus x, and this is all divided by 2 radical x plus 1. So we keep the denominator the same, and then we're just going to subtract the numerators. I apologize on behalf of my iPad for taking so. Thank you. Okay. So let's see, now in the numerator of the numerator, so this part here, we can simplify that because if we distribute the 2, we'll have some like terms to combine. Okay, so let's go ahead and do that. So let's distribute the 2. I'm just going to do that work over here because it's a lot to write. So let's do that'll be 2x plus 2, and then we have minus x. We've got 2x minus x, so that's 1x. So this will be x plus 2. All right, so let's see. So this is x plus 2 over 2 radical x plus 1. All that is over x plus 1. Okay. This is better, right? I mean, we have written it with fewer items like involved, and we've definitely gotten closer. However, this weird, totem pole of fractions here, this is a complex fraction still, we definitely not ideal. So let's review what to do when we have a fraction within a fraction. In other words, dividing fractions. So if we have like something over something divided by another something over something, right? In order to get out of this situation, in order to divide fractions, we take the first one and leave it the same, or the numerator one and leave it the same. Then we change this divide, the big divide, to multiply. And then we flip the denominator one. So instead of C over D, we're going to flip those and it will become D over C. Okay, so this is like keep, change, flip, if you learned it this way. All right, so we keep the first one. So let's see, we're going to keep the numerator fraction. So we'll have x plus 2 over 2 radical x plus 1. We're going to change this division into multiply. And then we're going to flip the denominator. How do we flip x plus 1? Well, remember, we can put anything at all if it doesn't look like a fraction. It kind of is. It's just a boring one. It's just got a 1 in the denominator. Okay, so we're just going to multiply by 1 over x plus 1. All right, this is kind of looking good. Now we just multiply across the numerators and across the denominators. So it'll just be x plus 2. We've got 2 radical x plus 1 times x plus 1. Okay, and last but not least, I mean, we basically have here, the same base raised to different powers and multiply. Okay, we have x plus 1 to the 1/2. We have x plus 1 to the first, or to the 1, and so we can combine those together. Okay, so we combine these, we're going to add the powers. 1/2 plus 1. Or in other words, 3/2. All right, so this will be x plus 2 all over 2 times x plus 1 to the 3/2. And, of course, let's look at our journey where we started, where we ended up, and it's definitely in a simpler place. So we definitely simplified this, and as far as we could go. Okay, so this was a challenge problem for sure. But this is basically the end of our algebra review. Like I said, we're going to be learning, reviewing, and strengthening our algebra skills throughout the semester. But this is the end of our formal algebra review. Next up, in chapter 1, we are going to review some things about functions, graphs, things like that, and then we will finally be able to get into our new calculus material. So stay tuned, and I hope you'll have a wonderful rest of your day.